This is a summary of Lee Cronin, controversial Nature paper on evolution of life and universe from the Lex Fridman podcast, where we break down the key insights, ideas, and takeaways from this content, giving you the gist so you can decide if you want the rest. This episode is brought to you by PerfectSummary.com. If you enjoy this breakdown, the Perfect Summary podcast is available everywhere, and you can find the video summaries on our YouTube channel at Official Perfect Summary. The discussion explores how chemistry might give rise to life and complexity in the universe. Lee Cronin's controversial theory of life evolving through chemical complexity, the possibility of building alien life in the lab, and its implications for science and philosophy. Introduction to Lee Cronin's work. Lee Cronin is a chemist and professor who challenges conventional thinking about life, complexity, and evolution. His recent paper in Nature posits that life is not a rare cosmic accident, but a likely outcome of increasing chemical complexity. He introduces a framework, assembly theory, to quantify how complex objects form, proposing that life is not binary but exists on a spectrum of complexity. Fridman and Cronin engage in a deep, fast-paced exploration of ideas that challenge foundational scientific assumptions about what life is, how it starts, and how information encodes purpose within physical systems. Assembly theory, a new framework for life. Assembly theory suggests that the complexity of a molecule, its assembly index, can reveal how likely it is to be the product of lifelike processes. It focuses on the steps required to assemble a structure from basic building blocks. Core idea: the more steps needed to build a molecule, the less likely it formed randomly, pointing to agency or biological processes. Relevance helps distinguish between biological and non-biological molecules in astrobiology or chemical experiments. Implication: life may not require cells or replication in the traditional sense. It may emerge simply from high assembly index systems that persist and evolve. Cronin argues that life isn't about DNA, cells, or even replication. It's about information being embedded in matter through history, enabling that matter to persist and adapt. Chemistry as a computational system. Cronin emphasizes that chemistry can compute, not metaphorically but literally. In his view, molecules and reactions can act as processors. Evolution itself is a type of computation in which persistence, replication, and selection are functions carried out chemically. Life is a form of computation using matter as a substrate. He contrasts this with digital computing, arguing that life's computations are messy, stochastic, and analog, but incredibly powerful. Building alien life in the lab. One of Cronin's radical goals is to build alien life, not by copying known biology, but by creating complex chemical systems with high assembly indexes, allowing them to evolve, persist, and adapt. Observing how these systems encode functions without relying on genetics as we know it. He believes this could allow us to detect alien life, not just by looking for Earth-like biomarkers, but by detecting high-complexity molecules, life signatures, based on assembly theory. This approach could reframe astrobiology by moving beyond assumptions about water, carbon, or DNA. Criticism and scientific resistance. Cronin discusses pushback from the scientific community, especially after publishing his Nature paper. Critics argue, assembly theory is too speculative. It lacks the predictive rigor of traditional chemistry. It challenges entrenched dogmas about life and evolution. Cronin counters that radical new ideas always meet resistance. He believes the framework will prove useful as it matures, particularly in origin of life studies and astrobiology. Information, purpose, and the universe. The episode dives into big questions. Can matter hold purpose? Does the universe have an intrinsic tendency toward life and complexity? Is evolution just a mechanism or a deeper universal principle? Cronin suggests that purpose arises when information is encoded in matter in a way that supports persistence. For instance, a molecule that catalyzes its own production has purpose. Its function increases its own persistence. A system that encodes constraints, e.g. feedback loops, is already doing computation. This suggests that life is not a yes-no phenomenon. It's a sliding scale of complexity and persistence. Implications for AI and intelligence. Fridman and Cronin also touch on the parallels between synthetic life and artificial intelligence. Both aim to encode purpose into non-biological systems. Intelligence may emerge from complexity and feedback, not from consciousness per se. Studying chemical systems that evolve could inform how we design AI that evolves, learns, or persists. This opens philosophical questions about whether synthetic systems, chemical or digital, can possess agency or intent. Closing reflections, the philosophy of life. The conversation ends on a reflective note about the nature of scientific progress. Cronin believes chemistry is not deterministic, and that's the source of life's richness. He urges young scientists to embrace uncertainty, challenge orthodoxy, and build bridges across disciplines. His ultimate message is that life is not magic, it's chemistry plus time plus information. And once we understand this, we may realize that the universe is teeming with potential for life, not just as we know it, but in forms we've never imagined. That's a wrap on Lee Cronin, controversial Nature paper on evolution of life and universe. From the Fridman podcast. If you found this summary valuable, make sure to follow, subscribe, and come back for more in-depth breakdowns of content. You can find this episode and more on perfectsummary.com, listen to the Perfect Summary podcast anywhere you get your shows, and check out our video summaries on YouTube at @official Perfect Summary.